Good morning to all. So today we'll start chapter 13, which is about correlation and regression. So first we need to understand the meaning of these two terms. You must have studied about correlation in class 12th, if you remember. I'll try to give you a summarized view. So okay, we'll just see this graph. As you can see, there is one x-axis and one y-axis. X-axis is called independent variable and y is dependent variable. Whenever suppose we change the values of x, the value of y, which is dependent on x, any property, it changes. So if we have got number of xy coordinate values, we can plot them as dots, which is called scatter plot. Now if we see this scatter plot, we can conclude easily just by seeing this that there is some correlation between y and x values. It can be seen that all the dots are in one direction, increasing direction. So what we are going to do here in this topic, correlation and regression, we'll try to find out the value of correlation coefficient. The range of value of correlation coefficient is from -1 to +1. If the value is near to -1, that means the value of y is decreasing with increase in value of x. And if the correlation coefficient is near +1, then it means value of y is increasing with increase in value of x. Now in the present case, it can be seen that both of them are positively correlated. Now what is regression? Regression is when we need to predict the value of y for any future value of x. Suppose we have got some values of x and y of these two coordinates, but what will be the value of y for a given value of x in future? If we want to predict, what we do, we find the equation of the straight line passing through these points, which is in the form of y is equal to mx plus c, which we have already studied in coordinate geometry chapter in class 12. So y is equal to mx plus c, where m is slope and c is intercept. Now in case of linear regression, we'll call these two things y is equal to a plus bx, and we'll calculate the values of a and b, and then we write the equation in this form, y is equal to a plus bx. Now let us start the question. This is first question of your chapter 13 of the exercise. In this question, they have given the laboratory reading and actual reading of carpet wear tester, and they have taken 6 samples, and number of rubbing cycles in the lab and number of passages in the actual condition is given. Now these are 6 carpets. These are number of rubbing cycles on the tester, and these are number of passages. Now we need to find the correlation coefficient between these two. This is your formula. For finding that, I have shown you the calculation, and we get the value r is equal to 0.967. You will always get the value between -1 and +1. So it is obviously very near to +1, and we can also see that as this value is increasing, this value is also steadily increasing. That means both the parameters are positively correlated. Now still we can find out the significance level of this correlation coefficient. So the mathematical procedure I have shown you here, significance of r, you will calculate this value, and from the t table you will find the table value and compare your calculated value. As we can see here, for 5%, table values are 2.78 and for 1% table value is 4.6 and calculated value is 7.603, this t value. So the answer is yes, that this value is highly significant at 99% level also, and it can be seen from this number also, because if it is near to +1, that means it is highly significant. But this is the procedure you need to follow. Now we'll move on to the second type of question, where we'll try to find the linear regression equation. Now in this second question, we are given the relation between relative viscosity of a dye liquor and the dye uptake on a certain fabric. Now this is X, which is relative viscosity of the dye. As viscosity of the dye is increasing, dye uptake is also increasing. We can see it here. Now we have to find the equation for estimating the mean dye uptake when the relative viscosity is known. So you need to read the question and try to understand which is Y and which is X. So now in this case we have to estimate mean dye uptake. So that means this is Y, which is dependent variable, and this is X, which is independent variable. So these are the calculations I have shown here, and we have to find the value of this A and B constant. Then only we can write the equation in this form: Y is equal to A plus BX. So for calculating the value of A, you need to do this Y bar minus BX bar, and for calculating the value of B, this is the formula you need to use, and these are the calculations I have shown. I'll provide these notes in text form also. So finally we get this equation: Y is equal to 0.313 plus 1.034x, where this is the value of A and this is the value of B, which is, this is slope and this is the intercept. Y is equal to mx plus c if we try to correlate with our earlier linear equation form. So now the second part is of this question is, what are the 95% confidence limits for the mean dye uptake when the relative viscosity is 4? So we need to predict Y and also its confidence limits. Okay, now this is a procedure I am showing you for finding the 95% confidence limits of Y when X is given. Now X is given here 4. So we'll start the process. This is for here we use the term gamma. Earlier we were using the term alpha in all the hypothesis testing concept. This is same as that. So this is for two-way 95%, alpha is 0.025, so here gamma is 0.025, and this here degree of freedom is n minus 2. So in our case 6 readings are there, so n minus 2 is 4, and for these two values, if we see the t table, we get the value 2.78. In this, first we have to calculate S minimum. I've shown you the formula here, and then we have to calculate this S standard deviation, and this is the formula for calculating the confidence limit for true mean value of Y, where A plus B XF will give you the basic mean value of the Y, and this is plus minus error part. So if we calculate, we get कि for XF is equal to 4, we get Y values as 3.3082 to 5.589. These are the 95% confidence limit of the Y value. So these are the only two types of questions we'll do in this chapter. Other questions in the exercise, they are not in your syllabus, so you have to just understand the basic meaning of correlation coefficient, and how to calculate this A and B values, and form the linear regression equation for a given data, and try to find the confidence limit for the correlation coefficient also, and the true mean value of Y. So I finish it here. Now we'll continue in the next class. Thank you.